Alright, hey there. So, this is the part of your week when I sit here and make a video, going through your study guide and just kind of going into detail with what everything says, and hoping that you watch this and so you'll do well on your exam. For those of you who don't know me, I'm Brittany. I'm a lab TA for the Tuesday afternoon and the Wednesday morning section of the lab. So if you're in the Tuesday or Thursday morning, you probably don't know who I am. So, I'm Brittany. So, let's get started. For your exam, which is on Wednesday, that's exam 2, there's some terms and concepts you were told to know. I'm going to go through the concepts first, and I might do the terms, but they'll probably sort of be covered throughout the concept lecture. The first concept is the relationship. Sorry. Preface this. I have a cough, so if I cough, sorry. So the first topic is the relationship between mycobiont and photobiont in lichens. If you remember, a lichen is a mutualistic association between a fungus and an algae. So things you should know, one being that myco means fungus. So, and photo technically means light, but you should think photosynthesis. So therefore, mycobiont is your fungus partner in this relationship, and the photobiont would be your algae because they're the ones photosynthesizing. Way you can think of this relationship is sort of like a landlord-tenant situation. If you've got an apartment, you've got a landlord, and you have to have a tenant because that's just how it works. So the algae's like walking around down the street, and he sees, oh, for rent, that's cool, I don't have any money. So he goes in and he's like, dude, I cook a lot. So if you let me make you food, can we work something out where I don't have to pay rent? And the fungus landlord's just like, sure, I like free food. Yeah, we'll trade off. You make food for me, and I won't charge you rent. So therefore, the fungus, or the landlord in this situation, gets free food and nutrients, and the photobiont gets shelter and a place to live. No more nights on the street for him. So, mycobiont gets food, photobiont gets shelter. Okay, so the next thing on the list is types of lichen reproduction. Lichens undergo fragmentation. Fragmentation, you'll remember, is asexual. So these guys are not undergoing a sexual life cycle, they're just asexual, popping off new guys and making new ones. There's two things that they can do when they undergo fragmentation. They can either make these little things called soridia, and those are propagules. And if you're watching this, propagules may not make a lot of sense to you. That basically just means they come off completely. They're almost spore-like in that sense, and basically they just get popped off and told, hey, Sonny, go find your way out in the world and don't come back. Don't write, nothing. We're just cutting you off. There's also Acidia, which is basically that 40-year-old who still lives in his mother's basement. Not really, but the Isidia does grow / branch off, but it never completely separates. They like to stay in contact with their family. So that's cool. So that's how lichens reproduce. And then we have the differences between endo and ectomycorrhizae. Endo means inside, and ecto means outside. So that should sort of imply where we're going with this. However, the complicated bit of this is that the mycorrhizae, and if you'll remember that the mycorrhizae is a symbiotic relationship between roots and fungus. Myco, again, meaning fungus, rhizae actually means roots. So, fungus-root relationship. That should help you remember what mycorrhizae is. So, endomycorrhizae are, like I said, mean inside, and ecto means outside. Now, the thing is we're not talking about what goes inside the roots and what stays outside the roots. Because to be a mycorrhizae, you're going to have to penetrate the roots. Now, where the difference comes in is within the roots itself. So, going to draw some nice little plant cells for you. And this is not an accurate representation. I don't want you coming up to me in a few months, or in a month or two, when we actually start talking about this stuff, telling me that my drawings look nothing like what you're looking at. I know. But for the purposes of this, it works. Okay, so I've got some endo roots and some ecto roots. So, you're in my lab. You've seen me do this quite a few times. With endo, you can find it surrounding the root cortex cells, which are all the dots in the middle. You can see the dots there. That's cortex cells, and that's what we're concerned about. With endo, it can surround it, but mostly what it's going to do is it's going to penetrate those cells and inject its materials into it. Yeah, not fun for the little cortex cells, but very helpful for them. With ecto, what it's going to do is it's going to surround those cortex cells, like so, but it will never penetrate, just surrounds them. They come out with their hands up. Just kidding. But they are surrounded by this mycorrhizal growth. What you see most commonly is endomycorrhizae, and that's in about 80% of plants. 80%. But basically what you need to know is endo is going to penetrate the root cortex cells and ecto will not. So that one's takes care of that. Okay, so the next bit of business is the two kinds of flagella and heterokonts. With heterokonts, what you should note is that hetero means different and kont means flagella. There are two types, tinsel and whiplash. There they are. One is long and skinny, and one of them is short and smooth. One of them is long and hairy, the other is short and smooth. But you need to know they're tinsel and whiplash.